Earth is 4.6 billion years old. But here's the kicker. We are only at halftime. The sun has exactly 5 billion years of fuel left before it fades to black. But if you think the first half of this planet's life was a quiet ride into the future, you're in for a shock. It starts in the dark. Before Earth, before us, the solar system is just a massive, violent cloud of gas and shrapnel. The sun ignites, and the leftover debris starts smashing together. Early Earth isn't a planet. It's a molten, boiling sphere of lava. There is no surface, just an ocean of liquid rock under a toxic, heavy sky. But Earth isn't alone in the dark. A rogue planet named Theia is on a collision course. It T-bones Earth at 25,000 miles an hour. The impact is so violent, it nearly shatters our world into dust. Trillions of tons of vaporized rock are blasted into space. But Earth doesn't die. Instead, that ring of molten shrapnel slowly clumps together, forming a silent, glowing watchdog in our sky. The moon. It locks our rotation. It tilts our axis. It creates the delicate, razor-thin balance required for life. But life is impossible right now, because Earth is thirsty, and the sky is about to fall. For millions of years, an unrelenting barrage of icy meteors and comets carpet-bomb the planet. As they crash, they melt. Slowly, agonizingly, they cool the scorched crust, filling deep, jagged basins with liquid. These are the very first oceans. But you wouldn't want to swim here. The sky is a suffocating orange. The water is toxic. But at the pitch-black bottom of these oceans, something is brewing. Superheated water, minerals, and volcanic gases mix in hydrothermal vents. And in that boiling chemical soup, dead matter suddenly twitches. The spark of life. Tiny, microscopic, self-replicating structures. They are blind, dumb, and small. But they are hungry. A group of these pioneers, called cyanobacteria, figure out a neat trick. They can eat sunlight. But there's a catch. When they eat sunlight, they release a byproduct, a gas that starts turning the iron-rich oceans a rusty blood red. That gas is oxygen. To the life forms of early Earth, oxygen is a lethal poison. This is the Great Oxidation event, and it triggers a mass extinction. The planet chokes on the very gas keeping us alive today. But it gets worse. As oxygen rises, carbon dioxide plummets. The planet's thermostat breaks. The oceans freeze solid. A mile-thick sheet of ice encases the entire globe. This is Snowball Earth. Life is pushed to the absolute brink of total annihilation in the pitch black beneath the ice. They are trapped, starving, waiting for a miracle that might never come. But the Earth's core hasn't forgotten them. Colossal volcanic eruptions rip through the ice, belching massive amounts of CO2 back into the atmosphere. The greenhouse effect kicks in. The ice melts. And as it melts, it washes mountains of nutrients into the ocean. It's a chemical feast, and it triggers the Cambrian Explosion. Life goes from boring, microscopic blobs to a violent, ruthless arms race. Suddenly, things have shells. They have limbs. They have eyes. For the first time in Earth's history, things are looking at each other and deciding to eat each other. Eventually, the oceans get too crowded. So a few brave, weird little creatures drag themselves out of the muck and onto dry land. Life conquers the dirt. It builds sprawling, continent-spanning forests. And in this warm, oxygen-rich paradise, evolution takes off its training wheels and decides to see just how big it can make things. For 150 million years, dinosaurs rule. They push the absolute biological limits of scale, power, and violence. They are the apex of Earth's design, unstoppable. Until a Tuesday, 66 million years ago. The dinosaurs didn't stand a chance. A 6-mile-wide asteroid wipes the board clean. But in the ashes, hiding in the shadows, are the underdogs, small, terrified mammals. With the monsters gone, they step into the light. Over millions of years, they stand up. They harness fire. They invent language. They build steel towers that touch the clouds. And they split the atom. But human progress comes with a bloody receipt. We are severely reshaping the climate. We are driving thousands of species to extinction. We are the new asteroid. And with 5 billion years left on the clock, Earth's ultimate fate, whether we build a restored utopia or turn this place back into the barren rock it started as, is entirely up to us. That's the legend. Now let's find out what actually happened. Okay, look, the story I just told you, the fiery birth, the ice, the dinosaurs, that is the pristine textbook version of Earth's history. It's a great movie. But when you actually dig into the science, when you read the geological papers, which I have been doing for weeks so you don't have to, you realize that science isn't that clean. It's messy. Let's start with water. Before, I told you that comets carpet-bombed the Earth and brought the oceans. That was the leading theory for decades. But skeptics and modern geologists are pointing out a massive plot hole. We can measure the chemical signature of water on Earth, specifically the ratio of heavy hydrogen to normal hydrogen. When we send probes to comets, their water doesn't match our water. It's the wrong flavor. So if the water didn't come from space, where did it come from? The strongest counter-theory right now is that the water was inside the Earth the whole time, trapped in a mineral called ringwoodite deep in the mantle. Under extreme pressure, this rock literally sweats water, which eventually outgassed through volcanoes to form the oceans. We didn't get our water from the stars. Earth sweated out. And what about Theia, the Mars-sized planet that supposedly hit us and made the moon? Skeptics used to hate this theory. It sounds too perfectly catastrophic. But then we brought back rocks from the moon during the Apollo missions. When geologists tested them, they found the oxygen isotopes were identical to Earth's. Not similar, identical. The moon is literally made of Earth. The Theia impact is practically a confirmed scientific fact. But that brings us to a massive, glaring mystery. The residue. The stuff we cannot explain. I told you about the Cambrian Explosion, right? Life goes from microscopic blobs to absolute monsters overnight. Here's what the textbook leaves out. Charles Darwin hated the Cambrian Explosion. He called it the biggest objection to his theory of evolution. Because evolution is supposed to be slow. But in the fossil record, complex life just appears out of nowhere. The skeptical, rational explanation is that life did evolve slowly, but they were soft-bodied creatures that didn't leave fossils. We only see the explosion because that's when things evolved hard shells that could be fossilized. But even with that explanation, we are still missing the biggest piece of the puzzle, the spark. I said earlier that in a hydrothermal vent, dead matter suddenly twitched. I made that sound so simple. It is the single greatest unsolved mystery in the universe. We know the ingredients of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. You can put all of those in a vat. You can heat them, strike them with lightning, simulate the exact conditions of early Earth. You can make amino acids, but you cannot make them alive. There is a gap in our understanding, a wall between complex chemistry and biological life that we have never been able to cross. Some scientists suggest panspermia, the idea that life hitchhiked here on an asteroid, but that doesn't solve the problem. It just moves the starting line to another planet. how did dead rocks become us? We still don't know. Which brings me back to the clock. We look at Earth's history as a straight line leading to us, as if humanity is the main character of the universe. But remember the dinosaurs? They ruled for 150 million years. We've been civilized for roughly 10,000. In geological time, we aren't even a blink. We are a rounding error. The residue, the uncomfortable truth left over when you strip away the legend, is that Earth doesn't need us. It survived boiling lava, toxic oxygen, global ice, and apocalyptic asteroids. In the next 5 billion years, continents will crash back together in a new Pangea. Oceans may boil away as the sun gets hotter. Whether humanity is here to see it depends entirely on whether we can outsmart the very natural disasters that created us. Earth is only at halftime, and the second act is unwritten. I want to know what you think. Are we going to outsmart the universe and survive the next million years? Or are we just the next dinosaurs? Let me know in the comments down below. And if you want to stick around as we unravel the biggest, most mind-bending mysteries of the cosmos, hit that subscribe button right now. And let's see what the future actually looks like.